Good morning, everyone, and welcome to Wednesday's IWTC-10. We're on our third day and getting halfway through the program. I hope you're still feeling excited. We've got just one topic to talk through today, but it's a very big topic, Genesis and track. Before then, we have a half hour, and I'm particularly excited about that because it's a live demonstration of Cyclogenesis. So we're demonstrating how we would go about forecasting a cyclone for the next 7 days in the formation. And for those people, and welcome to everyone online, we do invite your participation. You can put questions in the chat. We are not having a Q&A session for this first session because it's just half hour, but I'm hoping it will invoke discussion about maybe some of the things that are done in the Australian region may be applied for forecasting operations elsewhere. So it's my great pleasure to welcome my colleagues, so Rabi Rivet and Craig Earl-Spur, to talk about cyclogenesis in the Australian region. Thanks, Craig.
Yeah, thanks, Joe. As Joe said, my name's Craig Earl-Spur from the Bureau of Meteorology, and just starting off with a bit of a rundown. So we've got the satellite loop up here, the Himawari 8 imagery. Many thanks to our colleagues at JMA for this data. It's invaluable, couldn't do our jobs without it. This is the real-time imagery, and we're obviously in Australia, our area is 90 east, so middle of the Indian Ocean out to 160 east. You can see right now it's all pretty quiet. Bit more information about kind of our cyclogenesis and the products that we push out. So some of you may be familiar with the public outlooks that we have on our external website. They only go out to 3 days, though we do have some advanced work in introducing a much better, improved product that we hope to get up hopefully for next season, but we'll just have to see how things go. But in addition to that 3-day product, we also produce 7-day outlooks for mostly the offshore oil and gas industry in the north of Western Australia. And so we'll be looking at the full 7 days ahead this morning. We had hoped to be able to connect to one of our machines back in our office in Perth. Have actually got the connection up, but it's just a bit too slow to go through some of the tools there, but we've still got some good stuff that we're going to step through. So, as I said at the start, it's all looking pretty quiet across the Australian area at the moment, which makes it a little bit more difficult in terms of talking about what we would be looking at. It's also good news for us because it means that we can fully enjoy being here this week. But the areas that we'll have a look at this morning, we've got a bit of convection out to the west of Java and Sumatra. So that's of interest to us. Our area comes up to 10 south. We've got Cocos Island out this way, which got a decent sized community on it that can get in the path of anything developing out in that direction. And hopefully people have also noticed we've got this developing system in the Bay of Bengal. So we've got enough data loaded up today that we can even have a look at that as well, just as an extra way of demonstrating some of the tools. So I think we'll move to what we call the track map viewer, and this is a really cool tool that Rabi has mostly built on his own. So I'll move over to this side. So we're displaying a whole lot of ensemble members, the vortexes in each of those members, and we've got a huge domain here, so you can see there's plenty of data to look at. Right now, these systems are color-coded based on the model that they've come from. So orange is the EC, the kind of bright pink is the US, the GFS model. Got the UK MO in model in brown, and then the axis is the purpley sort of color. So we can step through time, we can see where each model goes, or each member goes, and we've got a couple of displays down the bottom here. Might be a bit tricky to see, but in the bottom right, is just a simple showing where the maximum wind with each member is relative to the system center. So we see them spread over a huge, well, we had them spread over a huge distance. It's kind of, we're looking at that to check, is this actually a developing cyclone that the model's picking up, or is it just found the vorticity with the max winds well removed from the center, and therefore thinking maybe it's not perhaps a cyclone, but there's some other interactions on the periphery of the system that are causing the model to identify it as a low of interest. As you see, Rabi's now just selected an individual system, so there's a clustering mechanism there that kind of tries to group these together so that we can see, the system of interest. Sometimes it works really well, other times it can get a bit tricky where it can have multiple systems located in a similar area, and we'd think that realistically those are probably all the one system. But it's just a way of slicing and dicing the data to really focus in on our areas of interest. This display down the bottom's showing the maximum wind speed over time for each ensemble member as well. So it's looking like the area of convection that is closest to our Australian area of responsibility. We might get a low from it, but the general theme coming out of these ensemble members is that it's probably quite limited in its development potential. Of course, we would do a full environmental analysis as part of the process as well to determine on our own the likelihood of development, but this gives us a nice way of just looking at a lot of ensemble data in a very quick and relatively clean way. Feel free to jump in at any time if you've got any comments you want to make, Rabi. So now that bottom display, we've switched over to wind percentage. So rather than showing the intensity of each individual member, we're looking at what percentage of members are meeting the certain wind thresholds. So the yellow lines are very weak. It's really just showing a circulation, but no development at that stage. Once we get into the green with 25 knots or 30 knots, so more that tropical depression stage, and then we've got blue and increasing in intensity, then purple and red for our gale force, storm force, and hurricane force winds. And so we can see over the next 7 days what percentage of models will exceed each of those thresholds. So this is really useful in terms of when our final products, our outlooks, break it down into a percentage. We know that thresholds, even as low as 5%, are of interest to the oil and gas industry when they're planning a response to an approaching system. So we can essentially use this to help quantify exactly what our probabilities are and really support a risk-based approach to responding to a cyclone threat. At the moment, it's also in 24-hour blocks, so each individual 6-hourly time step on that display is showing if that threshold was exceeded at any stage in the previous 24 hours, up to that point. There's an instantaneous one as well, which I suppose it gives you like a more idea of what's happening right at every individual moment. But when our products are done in a daily block, so you get a percentage for each day of the next 7 days, so that you might have systems that strengthen a bit and then weaken, and then the next one strengthens a bit and then weakens again within that 24 hours. If you did it on instantaneous, it might suggest that there's only one system getting that strong, whereas if you do it within the previous 24, then it will show that there's actually 2 of them. Obviously, when the numbers are that small, it's not a big deal, but when we're getting into many ensemble members, particularly running a super ensemble, with all the different ensembles that we have available to us, then it can make a big difference in the final result.
One thing we need to keep in mind is that the the different models have different characteristics. So yeah, some may be more keen for cyclogenesis than others. So typically when we're looking at percentages for outlooks, we're sort of looking at each model in turn to see, okay, well, EC's got this percentage. We kind of think that that's mapping to a certain chance of the system being a tropical cyclone. The Australian definition, being gales wrapping more than halfway around, sort of complicates things a bit. Whereas these values, that were the maximum wind values, sorry, the maximum wind values that we're looking at here, they're for a point. But yeah, that's just something we need to keep in mind during our cyclogenesis process. We can also look at past runs, which means we can see, one, how the model's been evolving, and two, what was the previous forecaster looking at when they issued their product, to see what's changed between now and then. So here we're loading up a couple more runs of the ECMWF ensemble.
And I suppose another part of that is you can see that the time that it goes out showing the percentage will decrease as older models are loaded in, because it'll only show where it's got data for every ensemble that you're including at that point in time. There's also other ways that we can view these percentages. So right now we're focusing on just the one system. We can confine that to within a certain domain. So in this instance, 90 east to 160 east being our Australian area of responsibility for cyclones. So we can have a look at, while this system might be developing, is it crossing over into RSMC, La Reunion's area, and therefore we don't need to include those higher percentages because we're really only concerned with the likelihood of a cyclone within our domain. I mean, obviously we're talking with La Reunion, but in terms of the products that we're publishing, getting that percentage so it's relevant for our area. And these can be, there's multiple domains that we use this for. In particular, when we want to focus on that offshore area to the north of Western Australia, we're then reducing it to 105 east to 130 or 125 east. And so rather than trying to have to manually look at it and think, oh, is it in the area, how many members are in the area and how many of those members are still a cyclone, it just very quickly gives you that answer itself. So in many ways, the numbers at the bottom is a very objective way of coming to an answer. So we know the limitations of it, things like, is the wind strength really associated with the intensifying core of the system, or is it something further on the periphery? As Robbie mentioned, our definition in Australia of gales having to extend more than halfway around the centre, we need to consider that in terms of whether this is counting to be one of the members that's exceeding our threshold of being a cyclone or not. And then when the clustering sometimes gives you those multiple systems where perhaps there should be one, we've got to factor all of these things in when we get our final answer. So there is still that layer of subjectivity into what we will publish in the end product, but yeah, this is just really useful tool in terms of being a starting point on which to start making those decisions.
Another useful feature of the map we're looking at here is we can color the fixes positions by the maximum wind. So again, the color scale is matching the percentages you can see here. Sorry, really, really close. So yeah, green for strong, blue for gale force, pinky purple for storm force, and red for hurricane force. And it can give an indication of different scenarios. So looking for one. Yeah, if there's sort of a bifurcation scenario where potentially staying weak and heading west, or in strengthening and heading south, we can sort of see that on the map in the scenarios, and it informs our communication process as well.
we have a look at the Bay of Bengal system,
Yep.
I think it shows a nice little display where we've got a pretty consistent story coming out of the models right now. So I can see that development over the next 24 or so hours before making landfall in southern India. So I guess you can see something like this, and it's an easy way of knowing that you can have relative confidence in what's going to be occurring over the next 24 to 48 hours as well. And a nice simple story there, I think, too. So it's nice to see it's when it's all kind of falling into line, as it is in this case, in terms of being able to communicate the meteorological story. And it doesn't look like the strongest of systems, but still, I'm sure those at IMD are working hard. So we'll going to bring up another example. So this next example is from earlier this year, tropical cyclone Anika that formed in the Timor Sea. So this was a really tricky system in the early days. You can see a whole bunch of ensemble solutions there. As they develop a system in the Timor Sea, or even perhaps to the north of Timor, the solution that we've got highlighted here right now is taking the system towards the southwest. But we can see there's also a lot of other solutions that are appearing to the north of Australia. In this instance, the ones out to further west, that's actually Tropical Cyclone Vernon. But the ones kind of further to the east of the coloured tracks at the moment, a lot of them are starting in a similar area to the ones that are selected right now. And certainly during this event, the deterministic models that we were looking at, there was a big split in the guidance, with some of them developing the system and taking it towards the west, as we're seeing right now. Others were taking it almost directly east, which presents a pretty significant forecast problem for us, and particularly when an area like the Timor Sea, there is still those oil and gas operations, but it's also an area where we have a border for our area of interest for a lot of those operators. So that the whole question of, is it in their region or out of their region, it becomes a bit more pertinent.
And then of interest, this is the analysis track that I've highlighted here. So in this case, significant difference between the forecast at that range and the resulting analysis. But this is almost a 7-day forecast, and it's also prior to the system even being analysed. So we only started analysing Anika, or the early stages of Anika, on Thursday, and this is from like the Saturday forecast. So fairly somewhat typical. Well, you can see how wrong the ensembles, well, I won't say wrong, how much difference the forecast can be from the analysis at that sort of time range. We can also look at the percentages for this one. So 1 second. Tick tock, tick tock. In this case, we can see that there's the position of the maximum wind relative to the centre down in the bottom right is quite close to that centre, indicating that there's not really that, we're not looking at a situation where the winds are being enhanced for us, southern hemisphere, on the southern side by the ridge to the south, indicating a reasonable chance of it actually being a tropical cyclone. But we'd be looking at wind fields and other diagnostics as well to sort of just confirm that. But in this case, you can't look through 51 wind fields in a reasonable amount of time. This gives a quick summary. And the percentages are taking too long. Yep.
So this is just a quick look at some extra guidance that, well, ways of interrogating the guidance that we'll use. So this is still the example of Annika, and very early on in the development of it. So what we're looking at here is the vorticity at various levels. We can see, I don't know if you can remember which color is which level, Rabi, but the key thing is we can see this elongated area of vorticity along the trough. When the systems are really deep, we'll have the red, the yellow, the green, and blue all lining up with each other. So, yeah, as you can see in these examples, so it's not only showing us just how vertically aligned the system is, but also how deep the system is in the model. And I think a lot of our forecasters, in terms of considering shear impacting the system, really like this display as a way of trying to diagnose that.
So it's focusing in on the effect of shear on the system rather than trying to diagnose the shear itself. So the stackiness of it, if it's tilted, then we can see that, yeah, shear is having an impact in the model. And yeah, red is 850 hectopascals, yellow is 700, green is 500, and blue is 300 hectopascals, which I suppose, yeah, it's representative about the depth of the systems in our region. We find, yeah, circulation to 300 is indicating a reasonably deep system, and is definitely very close or to being a tropical cyclone, or has the potential to be a tropical cyclone.
Yeah, and if we step through, we can see, because this is all the one model run, we're only getting about 72 or perhaps as far as 96 hours ahead of the base time for this particular example. We can see that although it got deeper and perhaps a bit more organized, then what doesn't last long before that vertical alignment actually starts to fracture. Was there one more? If we step forward, and we can see that the low-level center, this particular model run is taking it east, as I mentioned, when we're still looking at the ensemble solutions. Meanwhile, the deeper, or the higher level vortex is shifting to the south. So once again, this was a pretty tricky one in the cyclogenesis stage. In fact, through most of the cyclone's lifetime, this was a really tricky system to go through. Fortunately, wasn't the strongest. I think it reached category 2 and had impacts across the coast in relatively unpopulated areas, but still presents a forecasting challenge for us. If you step through one more, we've got, so still looking at Annika, now we're considering the moisture in the environment. We can see over where the circulation is, we've got lots of moisture over the Timor Sea, but then to the south, as we often do with the ridge on the mid-latitude anticyclone, lots of dry air, and so this is something that we'll routinely be looking at as well to see how close to the system center that dry air can get. It's typically always not too far away, and when we start to see it wrap around that western side and then the north, then we know that the system's, the potential for it to develop further is becoming much more limited, and it's probably getting closer to the end of its lifetime. In this instance as well, obviously, this system is developing very close to the coast. So whether it can actually get organized and develop prior to getting either crossing the coast or getting so close that the influence of landfall starts to really inhibit any further development is a constant question when dealing with systems across the north of Australia, particularly Timor Sea, Arafura Sea, and Gulf of Carpentaria that surround the Northern Territory, but it extends to a few other parts of our region as well. So this is the last bit that we've got prepared for today. We call this the postage stamp, and it's essentially just a very quick look at the actual nitty-gritty details of each ensemble member. So when we've looked at the previous ensemble guidance that's showing us the percentages, if we want to dig a little bit deeper into what's actually going on in each individual member, we can jump into this display. You probably don't want to spend too much time going through all the solutions, but it can very quickly draw your eye to the ones that are painting either the strongest systems or the weakest of the systems. So you can just get a better understanding of why there is that divergence in results. It might be that one of them's moving it over land earlier, or I guess if you identify which ensemble member you want to, you have a few more questions about how it's got to its solution, you can then go back to the other displays, pull up that ensemble member, and have a look at the influence of the things like the shear and the dry air on that system to try and explain or understand exactly what the results from the model guidance are that you're looking at.
Thank you.
Thank you for listening.
Thanks, Rabi and Craig. A round of applause. Just while we swap some technology, I think this is a great example of the decision-making process. Forecasters are having to advise on the likelihood of a cyclone forming, and that initial display highlighted the key things of being able to see several models at once, being able to combine them, being able to see the spatial differences, the tracks, the structure information, and the intensity all on one page. A key, so this is just a shout out to NWP providers and I'll say integrated data viewer developers, that forecasters are time challenged, and being able to see information on the one screen rather than many different websites or pieces of software where the displays are different, the colors are different, and the time to load is different, is all impediments in the forecaster's timeline. So having a display where we can look at multitudes of information sources is a really key requirement for the forecaster. And some of those outputs are targeted to the decisions that people are asking us, and being able to show that to customers and briefings and emergency services is really powerful, because you can see in the pictures much more easily than being able to describe verbally or written text. And I'll just note that for many developing countries without sophisticated tools, things like Windy, where you can do these things but it's limited, is becoming the preferred way to look at models. So anyway, it's a challenge. So I think we have our technology. I'll just mention online people. Apologies for the last couple of days, but we've finally got all the online chat sorted, so we're welcoming your input there. So thank you for joining in. We also have all the presentations available online now in PDFs. So for those of you who look at a slide and say, there's a lot of good information there, I cannot understand it all at once, you may want to follow on your device and being able to zoom or to look at the PDF yourself. So that's from the IWTC website. And if you go to the report documentation, the reports and presentations link on the homepage, you'll get the PDF of all the presentations for the week. And with that, I'm going to hand over to Rob to introduce our topic for the day, Genesis and track forecasting.
Thanks, Joe. So we're going to go into our next topic, as Joe said, TC, track, and Genesis. So before I bring Andrew up, I wanted to give a little context to this topic. If you think of TC track and you think of TC Genesis, those may not immediately go together in your mind. So the reason that we're going to be talking about those two things together this morning is because this topic has arisen directly out of a recommendation from IWTC-9 to develop probabilistic forecast products. And so there's a project called PFP, TC-PFP, Tropical Cyclone Probabilistic Forecast Products, that track and Genesis lend themselves well to probabilistic forecast techniques. So we're going to get, Helen Titley's going to give a summary on the progress of that project. It's, I think, at the end of their stage 1 now. So at the end of the topic, Helen's going to come up. But first, we're going to go through the various subtopics within topic 4. And so I'm going to introduce Andrew Burton, who I believe is the topic lead, along with Hui Yu. But Andrew's going to come on up and introduce the various rapporteurs to give their reports. And I do ask for all the speakers in the room, I should do it better myself, hold the microphone close to your mouth so that the people online can hear you clearly. So thank you. Okay, Andrew.
Thanks, Rob. And I'm very biased, but I think that Tracks map that you were seeing before is an absolutely awesome application. And on top of everything else that Joe was saying about it, I think it also shows the real value of having programmer meteorologists. Rabi developed that application, and he has the programming skills, but he also understands the problems that forecasters are facing. And that's why you don't need to hold it really speeds up the process. So thanks, guys, for that. This is, we talked a lot about, in the previous couple of days, about track in terms of, is it sort of a solved problem? I think we're going to see in the topic today that it's not. There's a lot of good material that we'll be covering. But first, I want to thank my fellow topic lead, Hui Yu, and the rapporteurs, Rajashree, KK, Ying Li, and Adam Conroy, for their efforts and for the efforts of the working groups. And hopefully we'll get a lot of discussion happening, and I hope there will be some time for questions at the end of this. So with that, I'll hand over to Rajashree, who I hope is online and ready to present.
Yes. Good morning, Andrew.
Thanks, Rajashree. Go ahead. Just just check your volume on the mic. Can you say something again?
Can I share my screen?
You can share your screen. You're a little bit soft. Is there any way we can turn the mic up a little bit?
Can you hear me now?
More, up to the maximum if you can.
I think this is the maximum I can.
Can you get the microphone closer?
Let me just... can you hear me now properly?
Everybody good with that? It's better,
Yeah,
yes.
thank you.
Thanks, Rajashree.
Hello, everyone. Myself, Rajashree from India Meteorological Department. I'll be presenting the summary of topic 4.1, Genesis, Controlling Factors and Physical Mechanisms. We would like to thank the WMO for giving us this opportunity, and we are thankful to the topic leads, Andrew and Hui. I would like to thank the working group members for their valuable input, discussions, and suggestions. The outline of my talk is, I'll be talking about synoptic scale controls, followed by thermodynamic conditions, impacts of shear, near equatorial tropical cyclogenesis, mesoscale controls, role of climate change, summary, and recommendations. Tropical equatorial waves. Tropical equatorial waves are the seedlings of TCs. Let me begin with the Western North Pacific Ocean Basin. A study carried out by Wu and Takahashi have shown that 2/3 of the TCG events over Western North Pacific Oceans are associated with one or two coexisting wave types. Similarly, in the North Indian Ocean, TCG is favored when more than one type of wave is present. In the Eastern Pacific Ocean, easterly waves initiation and evolution is controlled by MJO and Caribbean low-level jet streams. There are interesting case studies from the Atlantic Ocean. Nunez Ocasio et al. 2021 have proposed key predictors of tropical cyclogenesis over Eastern Africa. These include stronger northerly and West African monsoon flow, more intense zonal Somali jet and stronger convergence over the Mara Mountains, larger West African monsoon moisture and convective signature concentrated west of the Mara Mountains. Over the West Africa, the authors show the TC precursors include stronger West African monsoon, and more intense and extended AEJ off the west coast of Africa and offshore waters. On the right-hand side, the figure shows the conceptual model describing how the chances of TCG increases with appropriate convective coupling. The authors have shown that slower moving convections, mesoscale convective systems that are associated with developing African easterly waves provide the sufficient moisture and latent heat for the AEW vortex and thereby enhance or support the further growth. Oscillations and teleconnections. On the interdecadal time scale, Wang et al. 2022 have explained the basin-wide relationship, TC relationship with that is the teleconnection between subtropical east-west relay teleconnection, which is triggered by the Atlantic multi-decadal oscillation. On the interannual time scale, Chen et al. 2018 have shown that the variability is closely related with, or the TC genesis is closely related with the El Nino Southern oscillation. Other than the SST spatial pattern, the time difference in the onset of El Nino events have influence of TCG over the Western North Pacific Ocean. Pacific meridional mode also have influence over Western Pacific Ocean. On the intra-seasonal time scale, 20 to 70 day oscillation generally modulate the TCG frequency, whereas the quasi-biweekly oscillation, modulates the genesis locations over Western North Pacific Ocean. In a study carried out by Bharadwaj et al. Over North Indian Ocean, the TCG is favored when the convectively active phase of MJO is positioned over Eastern Indian Ocean. In an interesting study by Cao et al. Has found that TCG frequency has a significant positive correlation with the intensity of intraseasonal oscillation, but a weak correlation with the intensity of synoptic variation of environmental factors. The figure on the right-hand side shows the composite monthly evolution of the first PC and the second PC and the WNP TC frequency anomaly percentage related to its corresponding climatology. A combination mode formed by a nonlinear interactions between the Western Pacific warm pool, annual cycle, and ENSO variability has significant negative relationship with Western North Pacific TCG frequency on a monthly timescale from 1970 to 2019. Marsupial paradigm, there have been studies showing the enhancement of low and mid-level circulations. A vorticity budget analysis revealed mid-level circulation getting enhanced during deep convection. Study by Ravi and Walsh 2020 have shown that the strong positive Okubovi's theta parameter in the core of developing systems. In another study, Rajeshri et al. Have shown the presence of high wind shear, strong ridge, and cold seawater, and that didn't allow the system to develop. Yoshida and Fudeyasu studied the horizontal distribution of genesis environment under different flow pattern regimes. In terms of geographic locations, the TC genesis is supposed to occur in the eastern edge of areas of high genesis potential index and relative humidity with weak vertical wind shear. In terms of temporal evolution, the favorable conditions are gradually developing 3 days before genesis in the case of monsoon shear line and easterly wave regime, whereas 13 days before genesis in monsoon confluence region. A sea surface temperature is another important controlling parameter of tropical cyclogenesis. There are plenty of studies indicating various impacts of SST anomalies in North Atlantic Ocean and Indian Ocean on TCG locations and frequencies over the Western North Pacific Ocean. The input of ENSO and IOD, we can see that it leads to higher TCG in the southeast and Western North Pacific, whereas it leads to the lesser number of TC genesis over Northwest, Western North Pacific. Shi and Fang 2022 have shown a no typhoon phenomena in July 2020, and the authors have associated it with the high SST over North Atlantic Ocean. Over the Eastern North Pacific, the climate mode that influence TC genesis are ENSO, AMO, and PMM also have influence over TCG. Over North Atlantic, the list is as follows: ENSO, AMO, Atlantic Meridional Model Oscillation, dust and aerosols, as well as global warming. In a study carried out by Albert and Bhaskar in 2020, have shown that positive ocean heat content anomaly is an indicator of a high SST over the Bay of Bengal. Fudeyasu et al. Have shown tropical cyclogenesis is associated with higher SSTs in the Western North Pacific Ocean. The study has categorized under different TCG environments. Impacts of moist and dry air. A moisture pooling effect was discussed by Liang et al. 2022. That was for the case studies over Western North Pacific tropical cyclogenesis. Over the North Indian Ocean, Ramakrishna et al. 2019 have noted the presence of moisture convergence 6 days ahead of the North Indian Ocean tropical cyclone. In another study, Fudeyasu et al. Have shown the development of Kelvin cat's eye as one of the possible reasons for the persistence of the vortices. And the positive feedback, that is the near surface wind speed and the latent heat flux increasing the boundary layer specific humidity is discussed in Gavo et al. 2019. In the recent studies, the moist static energy has been used as a proxy for the moistening of low to mid troposphere. And there have been advances in the understanding of Mediterranean tropical-like cyclones. Increase in humidity induces early onset of genesis in Medicanes. And another study by Shifang et al., where there are different environments were considered, easterly as well as monsoon environments. The importance of mid-level moisture is higher in the case of WNP TCG associated with the easterly environments compared to that of monsoonal. Dry air intrusion generally reduces the thickness of moist, absolutely unstable layer. Also, longer residence time of dry air disrupt the vorticity or convective organization. Dry air in the lower troposphere may limit diffusive exchange, as shown by Sun et al. 2022. However, there are conditions like smaller core size as well as less vertical wind shear conditions can offset the adverse effect of dry air intrusion, as shown by Shimada 2022. Raymond and Kilroy 2019 have explained the importance of instability index in the inner ring compared to that of saturation fraction. Akhtar et al. In a study shown that large valleys of convective inhibition due to hot and dry air, creating a stable environment in the western northwestern region of Bay of Bengal. As shown by Hans and Bossat in 2021, the core of pre-Gabriele collapsed when it interacted with the mid-dry layer airflow layer. Now, Rajashree et al. 2021 have found that a non-developing system weakened because there was intrusion of dry air from the north of the core, and the trajectories were traced backwards to the northwestern part of India as a possible source, as shown in the figure on the right-hand side. Impacts of shear, as we all know, strong wind shear tilts the vortex tower. A tilted vortex tower will be susceptible for dry air ventilation, and the strong wind shear moves the convection down shear side as well. The recent studies were focusing on moderate wind shear because there are largest uncertainty of TCG forecast under moderate wind shear conditions. In addition to deep convection, recent studies have highlighted the roles of different kinds of convection in vortex reformation and precision. On the right-hand side, the figure shows the multi-scale interactions in Hagupit's genesis environment. On the synoptic scale, the active features are upper tropical trough and easterly wave that carries a marsupial wave pouch. On the meso-alpha scale, we can see the wave pouch and streamlines, cyclonic streamlines with the circulation center marked with the black cross and the mid-level circulation with the yellow cross. The overlaid over the clouds are the vorticity, and the vorticity dipole from tilting and stretching enhances the vorticity. And we can see the MCV over stratiform area as well. On the meso-beta scale, the local wind profile that is helping the convective organization that comprised of the winds from different trough, easterly wave propagation as well as cyclonic circulation within the wave pouch. And in the meso-gamma scale, we can see the convective cells, which actually generates the vorticity by tilting the horizontal vorticity in the lower level vertical shear and stretching it in the N cell as indicated in the figure of the local vertical vorticity. There have been studies indicating the possibility of near equatorial tropical cyclogenesis, provided that there are reasonably large enough source of background vertical vorticity present. Conditions are often more favorable over the Western North Pacific in boreal winter. The case studies are from Western North Pacific as well as North Atlantic basins. Kilroy et al. Have shown that there are chances of rapid intensification as well at the equator if near equatorial tropical cyclogenesis is possible. However, they decay rather rapidly also. Role of convection and heating. The probability and timing of tropical cyclogenesis is mainly depend upon convective characteristic, and based on the convective characteristics, we can differentiate a developing system from a non-developing system. Now, the total rain area, rain volume, and coverage area of deep convection, these all are very useful predictors for TCG in the observations. Kilroy have proposed an increase in cyclonic vorticity as a potential indicator of tropical cyclogenesis. The boundary layer physics of the large-scale vortex producing an Ekman pumping can be a possible key mechanism for convection maintenance and intensification. Vertical structure. The recent studies have demonstrated a novel technique to artificially induce misaligned vortices. In their model experiments in shear-free environments, they have identified advection of the low-level vortex towards the location of the mid-level vortex, also accompanied by mixing of diabatically generated vorticity maxima. Role of climate change. As we all know, there are two schools of thoughts. Number of TCs will be declining in a warmer world, and a few studies are indicating number of TCs will be increasing in a warmer world. There are studies showing no discernible trend in the last 4 decades. We are more interested in the regional trends in annual tropical cyclone frequency. There is an increasing tendency over the North Atlantic Ocean and a decreasing tendency over Australian region and Western North Pacific Ocean, and increase in the intense number of tropical cyclones over North Indian Ocean. And the aquaplanet simulations indicate increasing tropical cyclone frequency with the poleward migration of intertropical convergence zone. The figure on the left-hand side shows the observed linear trends in tropical cyclone frequency for the period 1980 to 2018. And we can see there is an increasing trend over the Arabian Sea and North Atlantic, also Central Pacific region, and a decreasing trend in the Western Pacific, coral seacoast of Northeast Australia and South Indian Ocean. The figure on the right-hand side shows the schematic of hypothesis link between the anthropogenic induced global warming and a reduction in annual TC numbers. Recent studies have shown that TC seed frequency played an important role in determining the overall TC frequency response to warming in climate change simulations. So in summary, recent studies have demonstrated the importance of understanding the potential effects of regional to hemispheric level scale variation in tropical cyclogenesis, and multi-scale influence of TCJ have been diligently addressed. Alternate pathways were proposed, and the development of TCs near the equator is possible, as discussed in the slide. And recent studies have focused on convection, vortex alignment, and developing as well as non-developing systems. And many studies require validation with real case studies, especially the modeling case studies. Understanding convective processes and improving model forecast. This will lead to the ability to make better decisions and at operational level. Understanding the impact of climate change on TCG has been remarkably improved in the last 4 years. Based on our study, we are proposing these recommendations to investigate the influence of spatial patterns as well as anomalies of SST on tropical cyclogenesis, to further understand the roles of water vapor and convection, continue the research on how different aerosol types interact with the tropical cyclogenesis environment, and multi-scale interactions in tropical cyclogenesis under moderate vertical wind shear needs to be studied in detail, and vortex resilience, precision, and reformation in sheared environments should be addressed. And we need to explore the convection physics and diabatic heating to improve the forecast skill of TCG prediction, to continue research on understanding the top-down and bottom-up mechanism of TCG in detail. Also, to quantify the stochastic process of convective development and tropical cyclogenesis. Understanding the regional climate change will be enhancing our knowledge, understanding of TCG and climate change. Thank you very much.
Thank you very much, Rajashree. We might hold off questions until the end. That will also allow us to just range the discussion across all the subtopics. So I'll go straight to KK Hon. Thank you, KK. We'll move on to look at Genesis in operations.
Good morning, colleagues. I'm KK Horn from the Hong Kong Observatory, and this morning I'll be presenting the topic report for 4.2, which is Genesis forecast process. It will be an operational side of the view of things. Thank you, WMO, for inviting me to this event, and also to the topic leads, Andrew and Dr. Yu, for their leadership. I also thank my working group for their excellent input, and as well, some of the contributions for RSMC New Delhi is also acknowledged to Dr. Mohapati, which is not written down here, but we'd like to thank him nonetheless. So in essence, tropical genesis prediction, we consider it as a next scientific challenge to the scientific and operational community after track and intensity. We have heard some excellent progress on the side of intensity forecast yesterday from some of the sessions. So this report, we will survey the operational status of TC Genesis related products by a number of major centers around the world, covering the key ocean basins and also both northern and southern hemispheres. This map, we borrowed it from the GMAS website of WMO, but I put it here to show roughly the geographical or spatial coverage of those centers we have surveyed around the globe for this report. So in terms of the structure of this presentation, first I'll go through the new forecast products by some of the major centers, then deal with their forecast process, followed by a few slides on the verification efforts conducted by these centers, after which I'll summarize and recommend. So first, sorry, there's some formatting error in the title of this slide. So we'll start with forecast products, and first we'll deal with the Western North Pacific and South China Sea Basin. The first input is from the RSMC Tokyo and JMA. So essentially on the left, you see that since September 2020, RSMC Tokyo began providing 5-day forecast for TCs which are expected to enter a TS intensity within 24 hours. So in this case, we believe it is for the TD which would develop into Tropical Storm Saudo in that year. So on the top right of that graphic, you can see it is called a TDA, since it is not named at the time. So you might consider it as a form of pre-genesis forecast, depending on how you view the strength of the system. On the right, the two graphics are a 2- and 5-day TCAP, which is Tropical Cyclone Activity Prediction Maps, developed by JMA to indicate quantitatively the probability of tropical cyclone formation. You can see the top one is based on JMA's very own GEPS, Global Ensemble Prediction System, while the one in the bottom is based on a multi-center grand ensemble approach. So the two of them have rather similar spatial patterns, even at the 5-day lead time range. But of course, the one based on the MCGE approach has probably a bit of larger spread, and as we know, would enjoy higher reliability statistically. So the next one would be CMA. CMA has been developing and issuing time spatial probability of TC formation in this run in real time, a product. It provides a 2-day and 5-day forecast. Essentially, it is based on a multi-modal ensemble approach, drawing predominantly using the EC, NSAP, and the CMA ensembles. So in the bottom 3 graphics, first you see the 5-day map, the 2-day and the 5-day maps. It is highlighting a couple of systems over South China Sea and Western North Pacific. And if you check the system to the east, it is indicating something like between the 2- and 5-day ranges, a system could have an increasing probability of formation, which is alternatively viewed in the graph to the right in the form of a time series plot. Also, the colored figure to the right would be a product which is available in real time on the CMA website, which shows the detection and potential forecast for tropical disturbances. These are categorized into 3 levels, low, medium, and high for the time being, which you can see over there, and of 2 potentially developing systems. The next one comes from Korean Meteorological Administration. Their National Typhoon Center issues 5-day forecasts for TCs which are expected to develop into a full-fledged tropical cyclone in the next 24 hours. I think in a manner analogous to the RSMC Tokyo forecast, which they first call a system under an investigation, like an analysis TD, which if it is expected to develop, then it would, forecast would be issued, and it's called a forecast TD. So the top right graphics is a probability forecast product developed by JMA. It is a quantitative product for TC Genesis, essentially based on an ensemble approach. They apply the tracker to each of the model members to compute the probability of formation of a storm in the respective areas. So here they also use a categorized probability approach in which they have low, moderate, and high probabilities. So the next one, we go to Pagasa, which is also over the Western North Pacific and South China Basin. The graphics to top, you've probably seen them in the Monday session. So that is a new product or service since 2020 by Pagasa. So they are providing a 2-week TC threat potential forecast, or TTPF, essentially using the output from a TC tracker on the NSAP GFS ensemble. The tracker is the collaborative effort between Pagasa and CWB. So essentially, that is a color-coded graphical product showing the chance of formation of TC in the respective areas or basins. These are accompanied by a textual description to the right. The probability levels are shown in low, moderate, high, but these are currently, I think, subjectively determined using certain checklists or workflow, but are not quantitatively given at this moment. So next is a new service by RSMC Honolulu, or the CPHC. So starting from season 2021, their forecasters have been doing regular email briefings in the form of their PDFs to their customers and users to raise interest or awareness of a potential formation of system. We of course note that genesis over the Central Pacific Basin is relatively rare, but on occasions where more significant threats might emerge, they also hold special video briefings initialized to their partners, which is from a good service. The next ones, we also have some excellent new developments from RSMC New Delhi. So since 2018, the IMD has been producing extended range TC outlook forecast covering the next 2 weeks. They are, okay, right. Their probability values are categorized in 3 levels, low, moderate, and high. Many of their bulletins can be found on their website, like the one on the right. In addition to synoptic and environmental discussions, they also include verification of the forecast over the past couple of weeks, which is an excellent feature. They have also developed a medium-range genesis forecast, which was extended from 3 days in 2014 to about 5 days in 2018. And they also hold annual forecast demonstration projects in the cooler season, which is October to December. And since 2019, they've been developing genesis forecasts covering up to the next 7 days. And also, as you see from the last bullet point, the IMD also introduced pre-genesis tracks and intensity predictions up to 3 days ahead, which are new developments. Next, we move on to the Southwest Pacific and Southeast Indian Ocean Basin. The Bureau of Meteorology, yes, operationally, the BOM produces 3-day outlooks for genesis in 3 of their interested regions, I think to the west, the north, and the east. They produce categorical probabilities on the first 3 days, and afterwards they switch to qualitative commentary. They're also developing a 7-day graphical forecast, which would be expected to be implemented in 2023. So this graphical product over here is based on the Access S2 guidance, which is the BOM's own seasonal or short-range climate prediction system. It is a forecast, I believe, if you check the small prints, would be the week 2 forecast over their region of interest. So they can give formation probabilities in such format as raw from the model, calibrated, and also different from the climatological normal for the areas of interest. So the system has demonstrated skill over climatology up to about week 5. So next we move on to the forecast processes of TC Genesis. So first we take a look at the RSMC Tokyo. So as many of us will know, they're still using the early delivery scheme, which has been immensely helpful to many centers in the region. So it helps to highlight early signs of developing systems, and these results are available in near real time in the NTP website, so it's available to Typhoon Committee members over the region. Essentially, as with many other centers, decisions to first issue a forecast track for a system would be based on a combination of approaches and evidences, including the observational, including satellite, and also available atmospheric and oceanic observations. Of course, reference is also made to the global deterministic and ensembles from various NWP centers, and of course their skills. We have seen gradual improvements over the years. For KMA, first the flow chart to the right, you can see their process for determining when to convert a TD under analysis to a TD which forecast track is to be issued. So essentially, it is based on consideration of a number of factors, including pressure patterns, winds, the break CI number, and of course the pattern of their satellite cloud features. Point 4 refers to the TCAF, which is a system developed by the KMA called the Tropical Cyclone Analysis and Forecast. They essentially consider a potpourri of 10 forecast factors, including various physical parameters, to provide a quantitative estimate of the possibility of TC development. So the graphics to the top left, you can see is the analysis of 3 systems overlaid on their GK2A satellite imagery. Right, and the next one is from Pagasa. So since the second quarter of last year, Pagasa has been introducing a more systematic approach or process for TC genesis monitoring and forecast, in which they follow a newly developed checklist to assess the chance of cyclogenesis for their 24-hour and 5-day forecast. So if you take a look at the wordings inside the checklist, you'll see that the workflow essentially considered a combination of observational evidence, model guidance, views from neighboring centers, and also consideration of large-scale circulation analysis and a number of other factors. So here, their probability values are assigned from unlikely to high. And additionally, through the reception of Himalaya 8 data, they also perform early direct-like analysis 4 times a day through their SAT8 software. Right. Next one, I try to pull the input from RSMC Honolulu and Miami together. So for CPHC, starting from 2022, their forecasters have the ability to view more amounts of model data on top of the United States GFS, and including also the European ensembles. So I think the FSU guidance, which is the TC log, is also a regularly consulted guidance. The image to the top left would be a snapshot from the NWS National Plan of Model Guidance. That is, this should be the 90th percentile of the MSLP plot, so indicating how the surface pressure patterns would develop. So for the NHC, they continue to make 2- and 5-day genesis forecast, 4 times daily for the Atlantic and the Eastern North Pacific Ocean. They also follow primarily a multi-model, multi-ensemble guidance approach, and using also the TC log product. So their genesis probabilities are provided up to 7 days ahead now, which is a new development since the previous IWTC. And I believe for the Central Pacific forecasters, they also continue to monitor various known climatological and the seasonal, sub-seasonal factors, and also consult the Climate Prediction Center's advice in the extent range. Next is RSMC New Delhi. These two are some of their flow charts and conceptual maps for determining genesis probability. There's some excellent materials here. So the left column are showing the flow chart for determining the genesis probability in the short to medium range, as well as the extended range. So from the top left, we see a number of key input, including the physical parameters such as ocean and atmospheric conditions, stability, and also environmental factors. While in the near term, obviously, more weight is given to the observational analysis, but it also includes consulting of the numerical model guidance. And for the extended range, a number of other factors such as large-scale processes, intra-seasonal oscillations, and etc. are also added to the considerations, while as the forecast range extends, there's naturally a greater weight paid to the extended range forecast model. While to the right is a rather involved workflow chart for their forecasters to determine and analyze a TC genesis process. So essentially, it starts with locating and identifying a system followed by theoretic type-like analysis. And you can see in the flow chart that there are also various routes which allows the forecaster to rule out a genesis process. And finally, for a system which is determined to have a chance for developing, then they will do it accordingly. Next, we also move back to the southern hemisphere for the BOM. The top left image, we've seen an excellent demonstration in the special session earlier this morning. So essentially, in the BOM, the forecast process is also largely based on an MCGE approach for deriving quantitative estimates. This excellent ensemble guidance viewer, which we looked at this morning, is showing combining information from the vortex identified from all the different available ensembles and models and their members, and has seen enhancements continually over the years. I believe they can even see ensemble or model runs up to 7 or 8 runs ahead, which is very good for comparison of behavior. One of the tools they use is the compilation of daily or weekly probabilities of storm formation, which incorporates considerations from the ENSO state. And it would be a useful tool for the forecaster to anchor their longer range forecast, and also to identify signals in which the longer term extended range models, how they deviate or show anomaly from the known climatology. Right, next we hope to move to the validation from available from those centers. This information is available. So for RSMC Tokyo or GMA, in their annual report on RSMC Tokyo, which is submitted to the Typhoon Committee, since 2020, in addition to the other excellent information provided, they have started to include a new verification of the time difference between their initial forecast and the actual occurrence time of a TC. So it's essentially the time between their first issuance of a pre-genesis track and the time that the system becomes a tropical storm. So you can see that that is the bar chart for the year 2021, all the named storms, I think 22 of them. So in general, you see a positive lead time. Many of them are between 24 or 36 hours, which is quite nice. But also during the peak season, we also see that some decrease in the lead time. And also there's one case, let me see which one, it's Storm 2111. I recall it might be called Anida. It might be a problematic case since it's formed at a relatively higher latitude, like 27, 28 degrees north. So it could be problematic. But in general, I think there's positive scale here. Of course, we all strive to produce even longer lead times. Next one is input from RSMC Honolulu. We acknowledge that genesis is relatively rare for the Central Pacific Basin. Over the last 5 years, in their own words, there were about 4,500 two-day genesis predictions. And the large proportion of them, like 90%, would be now predictions. And the fourth bullet point, you see that even for the medium forecast, unfortunately, none of the medium forecasts are verified positively with the system. However, of course, we note that the sample size is quite small. There are only 40 medium forecasts out of about 4,000. And the highs are even rarer. But we note that out of those highs issued 18 times in total, the storm actually developed 8 times after that. So I think that those are some reasonable successes.
2 minutes, KK.
Sure. The next one would be validation results from the NHC or RSMC Miami. So the left graph is the 5-day genesis forecast for East Pacific from 2016 to 18, while the right is the same graph for 2019-21. So we see a definitive improvement in the reliability statistically. The blue line is closer to the diagonal. For the Atlantic Basin, they also reported that there's no significant change in skill. So essentially, it's staying as reliable. Finally, we also see validation results from RSMC New Delhi. So they have been verifying their genesis forecast for the past few years, and essentially, the top row, the dotted lines are the reliability curves. So for low and mediums, they're reasonably reliable, while the high category for week 2 would be a little bit over. And they also did a similar validation for their 2 or 3 days forecast. Here, I think the dotted line is the is the perfect line, or the solid line is the reliability curve. So they are relatively skillful over that period as well. And finally, we have results from the BOM. So here, the blue dots are their validation results from 2016 to 2021. So essentially, these are very reliable results. They try to do a linear fit and give a slope of around 0.987, which is quite close to unity. So these are essentially reliable statistically forecast. So essentially, to summarize, we note that over the past years, centers have been developing new products and services related to geniuses in a probabilistic manner. Most of these are graphical or textual with categorized probabilities, and these are covering from a few days, 2 or 5 days, up to maybe 1 or 2 weeks ahead. So in terms of the forecasting process, we're essentially following a MCG approach by most centers, using all available models. So that highlights the forecast challenges, and the monitoring and short-term assessment continues to draw heavily on both NWP and satellite analysis. And finally, in terms of the validation, we see a steady or slightly improving skills, which is a good thing, and that also draws on the continued improvement of global numerical weather prediction as a whole. So I will not repeat my recommendations here. Essentially, we should continue keeping the benchmarking of results, noting the potential for intercomparison. Being from an operational center myself, I won't ask centers to try homogenize their products. And also, we should try to think more about how to engage users in delivering probabilistic forecasts. And of course, further scientific research, including AI, which isn't much covered here. Thank you.
Thank you, KK. Thanks, KK. And for the next talk, as Julian's coming up, I would like to give him a special thanks for stepping up at quite short notice to deliver the talk. Julian is one of the working group members, and he's presenting on behalf of Ying Li. So thank you very much, Julian.
Yes, thanks, Andrew. It's an unexpected privilege to be up here giving this presentation. As you'll see when the first slide appears, it's a very small working group. And yeah, it's Rapporteur's Ying Li, but we felt that it'd be good to do an in-person presentation, and since I'm the only member of the group who's here in person, here I am. So. Right, unusual tracks. The first question is, what do we actually mean by unusual tracks? Is there any kind of objective definition of that? And there are some studies which have tried to come up with an objective definition. And here we have a case from Zhang et al., which is looking at, for example, cases of very sharp turning angle or directional change between different quadrants, and having an objective measure of unusual tracks can be helpful, particularly if you're, for example, looking at model performance and how it performs in unusual track situations relative to the more usual tracks. And there are other studies as well which come up with a more objective definition. But I think for the purpose of what I'm going to present the rest of this talk, basically we want to not necessarily look at any objective measures, but just look at some of the controlling factors over particularly unusual tracks. And here's some of the factors which we've come up with through reviewing some of the recent literature. So first of all, the environmental circulation, the strength of the subtropical high, I suppose is a fairly obvious one, which can control the track of a tropical cyclone and particularly produce some unusual tracks. Other factors, interaction with a westerly trough or the presence of an upper tropospheric cold vortex. And in particular, monsoon gyres were found to be a particular case of producing unusual tracks. That can be controlled by the depth of the gyre or the relative size of the tropical cyclone and the gyre. For example, for larger tropical cyclones, they're more likely to collocate with the gyre, but smaller storms could have a more erratic track within the larger monsoon gyre. But I think there's more research needed to identify some of the flow configurations associated with those unusual tracks. There are also some physical process sensitivity, and there's some work by Orion Torn, who's one of the working group members, who found there was a high sensitivity to the near storm steering flow with tropical cyclones with unusual tracks. And other studies have looked at different cases. So we have Hurricane Joaquin in the Atlantic. The forecast track was found to be sensitive to variations in the convection scheme and the feedbacks into the subtropical ridge strength. And then there's also work which looks at asymmetry of adiabatic heating and how it's affected the forecast tracks for a particular typhoon, Typhoon Saola. So all these references within the working group report, if you want to look further. And another one which I think is fairly well known is changing in tracks due to interaction with topography. And we know that when typhoons reach, for example, Taiwan with its high topography, it can produce some strange changes in the track where maybe you have the lower level circulation decoupling from the upper level circulation due to interaction with high topography. And there's also track changes which can be due to the presence of and action with cooler ocean, because obviously we know the impact that can have on intensity, but it can also have an impact on track as well. Now, I think at this point, what I want to do is just kind of earth it in a few cases to illustrate some unusual tracks and the forecast challenges that it presents. So what I'm going to show is a few charts of a kind of multi-model ensemble plots for certain storms and how it was quite challenging in these cases. So this is a case of Hurricane Eta, which is a very unusual track, probably one of the most unusual in recent times. If you can see from that, if I can recap, Hurricane Eta formed in the Caribbean Sea, made landfall over Central America, and then doubled back over the Caribbean Sea, crossed Cuba, and then headed up towards Florida, turned back out into the Gulf of Mexico, and although not shown on this chart, eventually made landfall over northern Florida. Now, in this particular forecast run, the top charts are showing on multi-model ensemble tracks. You can see there's a whole variety of solutions. You have the storm crossing Central America, moving out into the East Pacific. You have dissipation over Central America, or you have a turn back over the Caribbean Sea. I put down the bottom there the NHC forecast for this time. So actually you can see that they made a good choice in terms of how they went with the possible solution at that time. Now, if I move it on a lot further to when by then the storm had got up into the Gulf of Mexico, and you can see at the top left a whole spread of ensemble tracks which went from anything from a southwesterly track right up to a northerly track. But in reality, you can see from the black line, the storm actually went northeast towards Florida. So actually, probably only one of those ensemble tracks actually captured what actually happened. And so again, NHC forecast in the bottom, that's probably as best that they could have done given the model solutions that were available at that time. Another case, moving into the Western Pacific, Typhoon Infa. This particular run here, you can see quite a large spread in the ensemble tracks, and they do effectively cover the track of the storm, which you can see in black. But of course, the track of the storm had this rather unusual 90-degree turn within it. And actually, although the ensemble covers the final track, not many of those members actually illustrate that sharp turn in the storm's track. Now, if we move it on, oops, didn't mean to do that. Oh, we cannot see it anyway. Sorry, I pressed something I shouldn't have done. Oh, that's better. Right. If I move it on to the next slide, which is a forecast from a little bit later, this is interesting because the spread of the ensembles is actually reduced, and a kind of natural reaction to that is, right, we have a more certain forecast. We can put out something which is a bit more certain. But actually now the observed track ended up being right on the outer edge of the plume. So what we're seeing is that in this later forecast, it gives a greater uncertainty of an incorrect solution. So I think that's something which needs to be kind of borne in mind from the forecasting community, that can happen occasionally. And then a little bit later on, the spread has widened again in the ensembles. So anything from possible landfall over Taiwan right up to Japan in this case. And then finally, as the storm was about to make that 90-degree turn, there was a bit more certainty in the kind of core of the ensemble plume, but still a lot of spread. But that's probably what you want. And I put a comment here that maybe not in this case where there is a fair amount of spread, but in some other cases, the ensembles are often not coming up with enough spread, and maybe strategies such as looking at more kind of targeted perturbations of ensemble systems, TC targeted perturbations could help in cases where there isn't sufficient spread. Other areas where we might get some large errors, there seem to be evidence that pre-genesis, there's errors in forecasts from storms which are in the pre-genesis phase. So in some ways this is kind of touching on KK's talk a bit earlier, and that the track forecasts are often poorer when initialized before the storm formation, as opposed to when you have something actually there in the analysis. And there may be a poor analysis of the initial storm disturbance, either in its positional strength, which may be causing that. And there's an example here, Hurricane Ida, the pre-Genesis forecasts. You see the tracks there all have a left of track bias compared to the actual observed track. And that can happen probably more so in pre-Genesis forecasts than in storms once we actually have a good circulation in the analysis. Another case where we can get some unusual tracks and some forecast difficulties is with multiple TC interactions. So this was a case from last year with Tropical Storm Conson moving across the Philippines, and Typhoon Chantu as well. And they were active at the same time, and they did, for a period of a few days, interact. And that produced a lot of difficulties with forecasting. So you can see this is one particular run from the models at this time. So the top one is forecast for Chantu, and the spread in the ensemble tracks had landfall anywhere from Hainan Island right up to Japan, with something of a bifurcation in those forecasts. And then at the bottom is forecast for Conson, which had a lower spread, but the eventual track, which was made landfall over Vietnam, was outside of that spread. So you can see the kind of potential problems there are with models handling the interaction of those two storms, which had relatively unusual tracks. And another case of looking at inland track forecasts and how we can get problems with that. In this particular case, you can see an ECMWF and CMA ensemble. This is for Typhoon Wefa, and they were both predicting landfall over China and the associated kind of impacts we would get from that, with a storm decaying and slowing down over land, and the inevitable rainfall impacts there could be from that. But in fact, in these cases, both models didn't handle it well, and you can see the top right, the actual track of the storm, which glanced the coast of China rather than making full-on landfall, and it carried on moving north. So what are the opportunities for improved forecasts? Well, we heard right at the beginning of this week about new observing technologies, and I think that could be something which is at least useful to focus on some of these unusual track cases and see if that can help improve any of these cases. And also, we've also heard a lot this week about artificial intelligence and kind of machine learning techniques and how they can be applied to various aspects of TC forecasting. And I think for the unusual tracks, that holds firm as well. And there's some studies there. There's quite a few, some references in the report as to how it can be applied. And Chen et al. Applied it successfully to forecasts of TC Genesis track and intensity forecasting. So I think that's another area to look at. So what are the recommendations from this topic? Well, we want to develop and apply strategies to hopefully identify potentially difficult cases ahead of time, and that enables the forecasters maybe to reduce their confidence in their forecast, because they know this is a difficult potential situation, and we want to address our forecast confidence appropriately. We need to enhance our understanding of the processes which are leading to unusual tracks. So as I've illustrated, things like when we have multiple TCs or multi-scale interactions or feedbacks from the convection and latent heat errors. And we need to identify strategies to improve initial conditions, particularly for pre-genesis disturbances. Are there any additional or targeted observations which might help? And targeting, doing specific TC targeted ensemble perturbations may help improve the spread in our ensembles, which has been an ongoing issue. And then, as I said, application of AI is something which we can look at in terms of unusual tracks, as well as a lot of other aspects of TC forecasting. And I actually took the liberty of putting on a final point down here yesterday, because I note in Rob's talk yesterday about recommendations from IWTC-9, one of the outcomes was that we have this difficult cases website. And from looking at it, I think it's a great resource. But from looking at it yesterday, I can see it's only got cases up to about April 2020. So I think it would be really good to keep that up to date. I would certainly recommend that we do that. And that examples such as the ones I've shown are added into that, and others as well as they are discovered. And I think that can be a really good resource for them being able to test all kinds of work that's going on, maybe in model enhancements, maybe in new observations which are coming online. We can test them on those unusual cases and see if there's any impacts there. So I would add that as an additional recommendation in this case. So I think that's just about it. I'll say thank you very much.
Thank you, Julian. We'll move straight on to the next presentation, which is a recording. Adam, if you're online, could you please unmute yourself and turn your video on? There's no sound coming with your video, so we're going to ask you to try to remotely present.
Okay, I can give that a go. Can you hear me okay?
Stand by. I think we might have sound on the video. This, by the way, is Adam Conroy, another member of the Australian Bureau of Meteorology Tropical Cyclone team and rapporteur for the track forecast operational capability and new techniques. And in this talk, there's quite a bit of overlap with the tropical cyclone probabilistic forecast products talk, but I think they sit quite nicely together, and I think you'll enjoy this talk. Should we? Okay, Adam, if you want, are you going to show the slides, Joe, or do you want Adam to share the screen?
I'm unable to share my screen at the moment because I'm on mobile backup.
Fair enough.
Okay, good morning, everyone. Thanks for this opportunity to present. My name is Adam Conroy. I'm a Senior Operational Forecaster, Bureau of Meteorology. I'd like to thank Topics leads, Andrew and Hui, for giving me this opportunity, and the members of my work group for their contributions as well. So my talk is on track forecast, operational capabilities and new techniques. So I guess the process of track forecasting itself is quite well developed. Most centres will use consensus methods to produce their OFTs. So probably more the focus of my presentation today is how there's a movement towards producing more situational dependent expressions of track uncertainty. And with the greater availability of NWP guidance, a lot of centres are now able to leverage super ensembles. So that is a good method for capturing the full spread of location probability. As AB mentioned, some of my topic was the findings of the TC PFP project. So Helen will talk to us about that afterwards. So I'll focus on the other aspects of the report. Sorry, I just have to sync my screen with what's on there. Yeah, so here's an example of a forecast track. Now, this actual forecast track is a real forecast track that was issued. It's the tropical cyclone Seroja. It was issued at IWTC 9th of April 2021, looking at the impact on the West Australian coast. I will be using this track throughout the presentation because it enables me to manipulate it a bit and show different ways for expressing forecast uncertainty. So that's why I've used this one Australian example, mainly because I have access to all the data. But through this report, we did look at many centres around the world. So on this track, most centres will generate a forecast track from a consensus of model guidance, and that track will typically show a position with some intensity and structure information overlaid over the top of it. The one thing with this part of the track is it does bring the user's attention to the forecast track itself, and perhaps takes away the focus from alternative scenarios. So it can be difficult to take these into account. In fact, you may have even noticed that on this example, I removed the cone of uncertainty, as we called it. But the eye is certainly drawn towards the forecast track. It can be difficult to assess what your risk is in this case, because, sorry, it's gone on to the next slide, unfortunately. But anyway, with this track, for example, you don't have a spread in impact of gales and that sort of thing. I'll try and stick to the next slide and catch up. So in the report as well, we looked at skill improvement trends in OFTs, and this study here, this image is from a 2018 paper by Lancy and Kalilovsky, and it was basically looking at have we reached the limits of predictability for tropical cyclone track forecasting. So we can see that overall the skill improvements have been slowing down or perhaps even stopping in this paper. There were similar trends shown in the Northwest Pacific with some improvement, but most of that is beyond 72 hours. So it does tell us that we perhaps can gain more by focusing on track uncertainty rather than any further improvements to the forecast track itself. So in terms of characterising track uncertainty, methods range from purely statistical to predominantly dynamic. Statistical is certainly the easiest to produce, that it has a predictable outcome, but it's not a very accurate depiction of the location of the TC, as it doesn't take in any situationally independent information. As we have a greater availability of ensemble NWP guidance, more operation centres are starting to produce dynamic pictures of track uncertainty. Hopefully it goes to my next slide now that I've caught up. There it is. So statistical methods. So in the Seroja track I presented beforehand, we presented here uncertainty based on the climatological average error of the last 5 years. The first area is 24 hours, the second area is 48 hours, and the southeast extension is the 72-hour uncertainty. So this is obviously easy to calculate, but with this sort of static area symmetric around the point, you can see we're potentially missing information. So when the track's accelerating to the southeast like this, you'd normally expect a long track uncertainty to be greater than a cross track uncertainty due to the speed of motion of the system. But in this case here, we can see that it's symmetrical, and as a forecaster, you'd sort of feel that perhaps it's not capturing the full situation because, you know, if something goes wrong, more likely it's going to accelerate to the southeast rather than go further left or right of the track. So with statistical dynamical methods, that's where we incorporate some dynamic information. It usually starts with a fixed error such as climatology, but some situationally dependent information is taken into account. It's often by manual forecaster adjustment. which in itself can be quite resource intensive, and being a subjective method as well, it can introduce individual forecasted bias. Another issue as well is when forecast the area no longer can be reliably related to an actual probability of it being within that area. So perhaps the meaning of the area is somewhat lost under those methods. So it can be an improvement, but not necessarily the best way to do it. Here's an example of an uncertain area that has forecaster input. So this started with the basis of objective guidance generating the base areas, and then the forecaster has gone and edited it to take into account a range of ensembles. So you can visualize compared to the previous example that the area has extended further towards the southeast to capture that potential acceleration. But yeah, as I mentioned before, it's quite labour intensive and can quite easily change from one forecaster to another. So looking at predominantly dynamic methods, that's when we can use ensemble data to try and estimate the probability distribution for the TC location. Now, I presented an example here from in India, the National Centre for Medium Range Weather Forecasting. So this is showing some forecast from back in October for a system approaching Bangladesh. It has plumes from the Indian National Ensemble Prediction System, the global model, and it's got strike probability and ensemble mean track shown on the right-hand image. So this can be a good way to express uncertainty. But when it's a single model, you typically be unspread. A single typically not sample all the possibilities, and while an improvement will not necessarily be giving you a full indication of where the TC could be located. I'll just wait for it to move on to the next slide. So looking at a way of improving this, where we can look at an ensemble of ensembles. So that's when you have a set of independent and skillful ensembles, and you can combine them to create a more complete representation of the uncertainty. It's similar to how a consensus of deterministic tracks will, on average, perform better than each of the individual deterministic tracks. So looking at Titley et al. In 2020, that demonstrated that a super ensemble of the EC, UK and US global ensemble models outperformed each of the individual models across all basins. So on that graph there, the grey bar graphs are the super ensemble of that guidance. Left-hand side is the global, and then there's 6 basins from around the world. And yeah, you can see in every case, did outperform the individual model. Super ensembles do tend to be overspread. But when you have an overspread ensemble, it can be good because you can at least sample the full location probability of the cyclone, and then with calibration, you can bring it back to something that represents probability. So using super ensembles operationally, it's not necessarily easy because you need to do it in real time and often for TC formation. So you would have seen the demonstration by Craig and Ravi before. So part of that display is all those ensemble tracks have been clustered to be associated with individual tropical systems. So that's an important first step to do that, because once each ensemble has each track associated with a system, you're then able to combine information for that tropical system across different ensembles and also different times of the model run. And then once you have the super ensemble for a system all together, you can use a suitable statistical method to generate a probability of distribution from these tracks. And then once you can calibrate that, then you can calibrate against historic performance to create an area that represents a probability of the system being within that area. So in this example here, this is now using the operational algorithm we'll be using at BOM in the coming season. So these forecast confidence cones, as we call them now, are based on super ensemble guidance. It's the 2 latest runs of the European model, UK model, US model, and the local Australian ensemble access GE. And these areas have been generated automatically from that guidance. You can see it captures a lot more of the acceleration of the system moving towards the southeast, a fair way further than the previous uncertainty areas did indicate. And hopefully soon it'll click over to the next slide. And when it does, I'll be overlaying the actual observed track, which will be shown in red, which you can compare how this track performed. Don't know if it can be clicked forward by someone. There it is. Okay, so that was the best track. So that last position on the track is the actual position that was observed at 8 a.m. on April the 12th, so corresponding to that last forecast position. You can see that it is within the uncertainty area. This example wasn't picked to show that this method is particularly better, but it did fall out in that case. But the main thing about this method is, as a meteorologist, the areas make sense from a physical point of view when you're looking at a system like this. It's not shown on this track, but the along track areas did grow large as the system moved southeast. So the actual coastal crossing time just north of Geraldton was around 8 p.m. on April 11th. So it crossed about 4 to 5 hours earlier than the forecast track indicated. I can't show it on here, but the actual confidence area for that time, the forecast confidence area, did contain that crossing point, whereas the climatological value would have fallen short. And when you're talking about impacts and using forecasts for impact-based decisions, knowledge of earliest onset of bad conditions is a very important thing for users to know. I've just overlaid a comparison of the methods here, zoomed in a bit. So the light grey method there is the uncertainty area that was based on climatological uncertainty. So that fell a fair way short. The medium grey area, and the label pops up, is what was presented as the second example, which was the objective area that had some forecast input. So it certainly went a lot closer to what was observed, but also in adding that forecaster input, a lot of extra uncertainty for the northeast of the observed track was added. So it was an improvement, but probably not the best one in this case. And then overlaid in dark black is that confidence area based on super ensemble guidance. I don't think I mentioned it earlier. I'm not sure I've got it on the next slide, but we've been referring to it as a forecast confidence cone because we're talking about a statistical distribution, so it sort of makes sense to talk in confidence levels, and it's also a more positive language than uncertainty. So just summarising, recent advancements that we've had in track forecasting since last ITWC have really been focused more on improvements into determining the probability of location of the cyclone. When we can harness the information from independent skillful ensembles, that's a very effective way of doing this. And I suppose it leads on to some of the talks coming later on in the conference. But an accurate representation of the probability of location of the TC is the first step towards better decision making. When you can combine that with information on intensity and structure, that gives the users their best ability to take all the information in and make decisions based on that. So yes, that's the end of my talk. Thank you to everyone. And yeah, I'll pass back to Andrew.
Thank you, Adam, and thank you for doing that under rather testing conditions. I think the idea of the video was to remove the possibility of technical problems. That didn't seem to work too well in that case, so thank you very much, Adam, for your effort on that. And I would encourage you, I like that presentation because it kept a coherent sort of story going through it, but there's a lot more in the report detailing how other centres are doing similar things to move from statistical representations towards situation dependent, in other words, taking account of the dynamical ensemble information. With that, I might leave this mic behind. So while we have a bit of time, I'll just mention, hopefully, I'm going to try to make this a fairly quick summary to leave a little bit of time for questions and discussion. And I just want to, at this point, invoke a former co-chair of IWTC, Jeff Keppert, to pass on his advice on microphone technique which is put it up against your chin. Foolproof. As soon as you do this, then your arm tends to go like this. Okay, thank you. And thank you to my co-topic lead, Hui. Let's move straight into this. So first looking at, this is just the summary points. So this is obviously 1 point per subtopic, is not doing justice to the topic at all. But the takeaways for me were that from the first talk, a range of observational, theoretical and numerical modelling studies have advanced our TCG knowledge. For those that are interested, I think you found that there was a lot of different material, a lot of different papers referred to by Rajashree, and I'd encourage you to look at the paper and to follow that up. I think it was very encouraging to see the progress that's been made in Genesis products. I think in the last 4 years, there's been a really significant advancement in towards more probabilistic Genesis products, and we saw improved reliability in the probabilistic forecasts. It's quite clear that we need more research into unusual tracks with high forecast errors. One of the things that you'll notice that it was a very small working group. There doesn't seem to be very much research going on into track at the moment, and hopefully we'll have time to discuss whether or not that's a reasonable thing or not. I don't think it is, because I think there's still quite a bit of, and I think that we saw with the unusual tracks, that there's still quite a bit of really problematic cases, and they can have a very high impact. So we really need to focus on them. Even if there might be a small proportion of cases, they have high significance. And then finally in Adam's talk, and you'll see in the report that it's very encouraging to see an increasing use of NWP ensembles to convey the situation-dependent track uncertainty. And the images down the bottom are just for colour, really. They're just showing a bunch of different track products. So in the Genesis research, as I said, there was quite a lot of material presented. I encourage you to follow up on that. But the things that particularly I wanted to highlight were the knowledge of the complex multi-scale interactions involved in tropical cyclogenesis has advanced, more research needed. And I think it was very interesting to see the schematic of the multi-scale interactions in Hagopit from the Nam and Bell paper. And I also picked out, one of the themes that I picked out of that report was that the majority of TC Genesis events are credited to a combination of the equatorial wave types, with the Kelvin waves having the least significance. Understanding the impacts of ENSO and Pacific meridional mode on tropical cyclogenesis on an interannual to interdecadal timescales has improved. And this came up the other day as well. A lot of talk about research into cyclogenesis under moderate shear. It came up in the context of intensity. And really, if we think about it, in a way, Genesis is just a part of the intensity spectrum. It's part of the intensity question. So I think there's definitely need for more research into that area of intensity under moderate shear, right through from Genesis through the life cycle. The role of climate change continues to be studied. And what was interesting to see the different results coming out in relation to climate change. More TCs, less TCs. And also recently there are some indications that we may not yet have fully disentangled, if you like, decadal modulation from climate signals. I think there's a need for further research into that area. And the diagram here that you saw in Rajasree's talk showed the link between anthropogenic-induced global warming and tropical cyclogenesis. My takeaway looking at that diagram was that it's complicated. We move into the Genesis operations and the forecast processes that are being involved, and encouraging to see there's less movement in the multi-week time frame than in the 1 to 7 day time frame, but there's still some notable progress. The Pegasa multi-week cyclogenesis forecast and the that we're looking at here. There are other, and we saw other agencies also getting into this space. But I'll move on to the next one. So then coming into the more into the 7-day time frame, we saw that there's quite a lot of activity in this space. One of the things that with this depiction of the JMA ensemble versus what you get with the multi-centre grand ensemble or super ensemble is you do see that there are additional areas. It reinforces the point that Adam was making, that a single ensemble is often underspread. And here we're seeing that a super ensemble is highlighting additional areas of risk. I do want to mention actually one thing about this one is that we are seeing in some of these, as we move into this space, there are some agencies presenting uncalibrated probabilities, essentially a heat map style, and there is value in that. But the next step beyond that is to get to calibrated probabilities. And that is adds a lot of value for the customer, but is by no means a simple step to take. It's very encouraging to see that improved NWP skill and intensity seems to be underpinning an improved reliability scores for quantitative probabilistic Genesis forecasts, as we saw with the across a couple of several agencies, with the reliability scores improving. This may also be the use of consensus techniques effectively, the use of a super ensemble also adding, so not just the baseline increase in the NWP skill, but the application of effectively consensus techniques in this area, yielding additional skill. And then looking at, to summarise the Genesis operations, we already covered the increasing availability of multi-week Genesis forecasts, longer lead times being produced for Cyclogenesis products in the 7-day range. We saw a number of agencies producing tracks for systems that were expected to develop within the next 24 hours. Some agencies, such as NHC, are experimenting with 7-day Cyclogenesis forecasts. And as you saw this morning, the Bureau is engaged in 7-day Cyclogenesis forecasts, which, as you saw, is very challenging. But from a customer point of view, from the public's point of view, emergency managers, it's very important that they understand all risks. And for some basins, and it's true in the Australian basin, we can have cyclogenesis occurring close to the coast. And so if we were to wait until we had an observable tropical depression to start warning about, we would give less lead time than people are asking for. So we've kind of been driven into this space of doing the cyclogenesis forecasts solely from NWP in order to provide the information that's needed by the community. And we did see a trend from structured subjective forecast processes, the sort of checklist approach, towards objective processes based on super ensembles. In unusual tracks, despite substantial advances in the track, in the skill of the official forecast track, that skinny black line, if we want to call it that, we've seen significant progress in that. We've even seen the question being asked, are we reaching the limit of predictability in the shorter time ranges? And yet, even against that setting, we're seeing very significant errors associated with unusual tracks. And these can have very high impact. One of the things I picked out in that paper was that I found very interesting was research in the last 4 years suggests that some flow configurations, some steering patterns, such as a deformation pattern, are commonly associated with unusual tracks. So if you think about a deformation flow with the axis of contraction and dilation, if the center moves to one side or other of that axis of contraction, it can increasingly move further and further into a different steering pattern and result in large forecast errors. Now, if we can understand that, that this is a scenario where there might be high error, that does add value to the forecasts. We noted the larger track errors for pre-Genesis forecasts, and that interaction between two or more tropical cyclones continues to be a difficult forecast problem. And finally, to summarise the final talk, track and operational capability. I think going back to a famous line from ex-director of the National Hurricane Centre, Max Mayfield, don't focus on the skinny black line was, I believe, an admonition of his that to people, don't focus on that, think about the uncertainty. And I think it's encouraging to see that operational centres seem to be heeding that advice and driving towards those probabilistic forecast products in this situation as hard and fast as they can. And I think that as the skill of that skinny black line, the official forecast track, as it's sometimes called, begins to plateau and ensemble NWP becomes more accessible, and accessibility is an important part of this, emphasis is shifting towards situation-dependent depictions of track uncertainty. The use of super ensembles provides opportunities for the quantitative probabilistic services, but there are technical challenges. And some of those technical challenges start with the tracking and clustering. They start with the vortex parameter files that come out of the ensembles. It's, I really can't think of another way. And when you're faced with that amount of data, you're looking at 200 ensemble members in a super ensemble, things like the software that Rabi has developed are necessary to be able to condense that information down into a way that forecasters can deal with it within the timeframes that they have. And there is no perfect tracker. There is no perfect clustering algorithm. And I think there's a lot more work needed in this area to make sure that as we move forward, we optimize and to the degree possible standardize those processes, and that we make sure that we, because of the technical challenges that are involved, that we approach this globally in a way that makes sure that we don't leave people behind, that we don't end up with just NHC and maybe the Bureau and a few others who can afford it and overcome the technical challenges in a situation where they can exploit all the super ensemble data. I won't go into it now, but I think there are ways that we can do that. So that were the summary points. I'm not going to go through the recommendations in the interest of time. So I think I'll just stop there, and I'll leave that up there while I... I'm going to see if... Actually, let's go to Helen and do questions. All right, so we might delay questions until after Helen's talk. So I will hand over to the co-chair. Thank you very much.
And if you hadn't gathered, the genesis and track was being together was precipitated by the PFP project, and Helen Titley from UK Met Office will present on the project. Thank you.
Thanks, Joe, and thanks, Andrew. Yes, so I'm Helen Titley from the UK Met Office, and for those of you who I haven't yet met, I hope I get a chance to talk to you over the next few days. I'm here to talk about the Tropical Cyclone Probabilistic Forecast Products Project, or TCPFP. And on this slide, it lists the members of the project team, which includes Monahiko and Anne-Claire, who are both here. And I just want to particularly pay thanks to Jason Dunnion from NOAA, who's our TCPFP chair, who's helped with putting together this presentation. So a bit of background, first of all, to TCPFP. So at the last IWTC in Hawaii, it was identified that there'd been a kind of slow pull-through of ensemble-based probabilistic guidance and uncertainty information into the operational TC forecasts and warnings and the products. And so one of the recommendations, there were a number of recommendations related to this topic, but the overall recommendations was that more effort go into this pull-through of ensemble forecast data, and particularly using an interdisciplinary approach to address that. And so as a result of those recommendations, the WMO WWRP launched the TC-PFP project as a seamless GDPFS pilot project. And I just take a moment of kind of personal reflection in a way, because I've been involved in the ensemble forecasting of tropical cyclones for over 15 years now, and I've been passionate about trying to improve the pull-through of ensemble forecast data into operational TC products and warnings. And this morning's session has just been fantastic to see the development in that since the last IWTC, and in KK's talk, looking at the work in Genesis and the great work that's been done there, and then the talk we've just seen with the great work going on at several centres, and particularly highlighting the work that the Bureau have done. It's a really exciting time, and so yeah, the TC-PFP project it's so great for us to see this kind of pull-through happening. So what's the purpose of TC-PFP? So we hope to coordinate across the forecast centres, so the RSMCs and the TCWCs and the NWP centres, to help to identify best practice guidance for probabilistic tropical cyclone forecasts, because we want to promote the transfer of ensemble information from research to operations. And we know that all centres tend to use cones or circles to express forecast uncertainty, but historically and traditionally, the size of those cones and circles has been determined from historical forecast errors, although, as we've seen, that's starting to change, and that's great. And that's important because forecast uncertainty, varies a lot from one TC to another, and even from one initial time to another. And I won't spend too long on this, but just to emphasize the point, similar parts of the world, different storms, looking at individual ensembles and a multi-center grand ensemble or super ensemble, you could just see, how different it is from case to case. So really pulling through that ensemble-based situation-dependent uncertainty into the operational forecasts, can give really crucial information, not just on uncertainty, but crucially on when we're more confident than the average. And so yeah, that's the kind of aim behind our project. And we have 3 phases. And so the first phase, which is coming to a close now, which we've been working on for the last couple of years, was looking at TC formation and position. The next phase, starting next year, looking at intensity and structure. And the final phase, looking at rainfall and storm surge. And in each phase, working to help identify best practice for probabilistic forecasts, and crucially using a kind of a value cycle approach. So you may remember back to Brian Golding's presentation on our first day, where he showed the high weather value chain and value cycle diagram. And here in our project, we're really aiming to ensure the flow of ensemble data through that forecast chain across those bridges to crucially make sure that we're maximizing the benefits, but crucially also that we use a value cycle approach, where when we're designing products, we're seeing the users not as kind of end users, but partners in co-designing the product information. And so yeah, that's what we're trying to use in this project. The main accomplishments so far: in 2021, we carried out a survey of the forecast centres about their current efforts and their plans for probabilistic forecasts. And then one of the big achievements of the project so far has been to have a 3-day WMO-sponsored workshop looking at TC, Track, and Genesis probabilistic forecasting. And I'll show some of the results of that in a moment. This year, we've done another survey, this time focused specifically on access to ensemble TC track data. We've also, there's been a small funded study on tracking algorithms, which I'll show a slide on. And then we've been preparing our end of phase 1 document, which we hope to publish early next year. and presenting a summary here. And thanks to Adam, because we were able to include some of our results in subtopic 4.4 as well. So do look at that subtopic report for more information. So a bit more on that workshop. We split it into three days, looking first of all at what were the current and the planned products. Day 2 was focused on that crucial issue of ensuring that we use social science expertise to help to understand how best to communicate and formulate those products to communicate uncertainty information. And then the final day, looking at resources for producing probabilistic forecasts. And from this workshop, we identified writing teams to help us summarize the findings and the recommendations, which I'll show at the end of the talk. Just to say it was a really successful workshop. It was virtual, but we had over 100 participants from 14 different time zones and 16 countries, with a mix of mainly forecast centers, but also NWP centers and from research. So a good mix of participants. As I said, I'll show the outcomes from that in a moment, but I just wanted to, I've got this slide on the questionnaire we did this year about the data access side of things, because this is a really important point that I think we can help to improve. Because at the moment, the operational centers rely heavily on kind of bilateral agreements between NWP centers and the forecast centers, and also the internet and sometimes other agencies to get the ensemble data, rather than on like the GTS. And so there's significant differences between the centers in terms of the data they can access, and actually there's sometimes even different acquisition times for the same data. And so this inequality could actually lead to greater differences in the quality of services that forecast centers are able to provide. So this is an important area to try and address. So we concluded that we need to ensure that the forecast centers can get reliable and timely access to ensemble forecast data, and ideally standardize the data formats, including, crucially, ensuring that we provide code to enable the effective use of that data, because there's a lot of different data formats at the moment that the centers are having to deal with. And then, crucially, ensure that all NWP centers include pre-genesis tracks, so for TC's forecast to form during the forecast, because that's not provided at the moment from all the ensemble forecast systems. I don't have time to talk about this in too much detail, but this is the study we did to start looking at differences related to the tracker used in each of the ensembles. And Zhangbo is actually here somewhere. I don't know, Zhangbo, do you want to put your hand up? Yeah, Zhangbo's down at the front there. So if anyone has any specific questions on this, do find Zhangbo at the coffee time. But basically, in this study at the University of Reading, they looked at using 4 different trackers on the same data set. So EC ensemble forecasts in the Northwest Pacific in 2020, to specifically look at what differences are we seeing that are purely based on the tracker method used. And actually, there weren't too many differences. It's got the spread and error shown on the right there. And there aren't too many differences in terms of the spread, a little bit more in the errors that are shown. But what's interesting is just, there's quite a large difference in the kind of sample size in terms of the track points. And this is really due to kind of differences in feature identification and kind of the variables and the thresholds that are used in terms of kind of what it identifies and crucially when it dissipates a storm. So there are big differences between the tracker. And I think Zhangbo is still going to do more work to kind of try and understand more clearly the causes of these sample size differences and to kind of check the results and investigate them more across other basins and years. So in terms of the main findings and recommendations, and I apologize for how much text there is on this slide, I'm very sorry. But I know you're all probably desperate for coffee as well. It's a bad slot right at the end. So I'll try and run through quite quickly. But what we found is that this exciting time where so many of the forecast centers are independently, developing and advancing techniques for pulling through ensemble forecast data. And although each center does have their specific stakeholder needs, they're all sharing the same challenges. And so oh, that's okay. Sorry, I thought I'd lost my mic. So there's a definite need to ensure that we have more kind of regular and specific communication between the centers on this topic as they all try, because they're all, independently, working on this. And really, it would be great to be able to pool their knowledge and their expertise on how to optimally exploit ensemble forecast data in their products. And similarly, it would be great to have more kind of coordination of that interdisciplinary research on how to interact with end users to optimize the kind of product design and the communication. So I think it would be great to kind of work more closely across the centres on that. So one of our recommendations is that WMO continue to help facilitate these ongoing opportunities, because like we've started that with TCPFP, but we really need to ensure it's an ongoing process to exchange the information, and hopefully to try and enable a kind of semi-standardized set of best practices. And the reason for that is to kind of prevent a kind of divergence in approaches. You know, there may be reasons why the needs, you know, not completely standardized, but it would be great to kind of try and at least semi-standardize those approaches. And then, crucially, we found that not all centres are able to effectively use ensembles because they can't access the data with those multiple data formats and delivery mechanisms hindering the progress in that area. So we identified a need for the track data to be made available in a timely, kind of stable and consistent format to enable the pull-through of those grand and super ensemble track forecasts into the operational forecasts. So my last few slides is just to give a bit more on each of these. I've grouped these by the 3 days that we had at our workshop. And what we did is we highlighted and identified kind of 6 key areas where it's important to continue that ongoing communication between the centres. And the first one is, you know, how should we optimally weigh and combine the forecast information from the multiple ensembles and also the other deterministic models that are around? Because we know they have, you know, varied model resolutions, forecast skill and biases, and this crucial issue that Andrew mentioned of ensuring that, you know, we optimize and calibrate the output from the ensembles. And also the fact that depending on when your operational timings at the centre, you might be having the ensembles from different forecast cycles depending on when they're available. So, you know, that's all important to consider. We also, you know, we need to look at the optimal combination of this dynamic uncertainty information with climatological information. Should we be switching to a purely dynamic based information, or is there still a role for combining that? I think it's important to look for kind of innovative approaches on how to exploit the detailed information that the ensembles can provide, because the true uncertainty is kind of rarely centered around a central best estimate. So it's important to kind of try and exploit kind of that more detailed information that they provide. And then one challenge is obviously sometimes there will be genuinely really large uncertainty. And so there needs to be a focus on how can we produce kind of an understandable and actionable probabilistic forecast product to stakeholders at all levels of forecast confidence, including those kind of large uncertainty cases. And, you know, I really like the terminology that the Bureau have used with the forecast confidence cone, because I think it's, you know, recognizing the value of the information of confidence rather than focused on, you know, how much, you know, uncertainty there is. I think it's a great, just by turning it around to be a more positive thing, I think that can help with the communication aspects. And I think we saw earlier on in the week the nice product that NHC provide in terms of the arrival time of tropical storm winds. And I think products like that communicate the kind of a long track uncertainty, you know, ensuring that those products like that can pull in the uncertainty information. Because, you know, often there is a focus on kind of cross-track uncertainty, and actually those, you know, a long-track uncertainty can sometimes be greater, and it's important to communicate that as well. More on understanding and communicating the products, TCPFP, you know, it was recommended that we continue to emphasize the hazards and risks as well as just the track. And some recent risk communication work has said that actually emphasizing alternative outcomes and visualization can support decision-making. It's important to consider how to communicate several distinct outcomes. So in the case of like genuine like bifurcating tracks where, you know, a storm might either recurve or not. And you might actually have a case where it's split into 2 clusters, each that have very different regions being impacted. And it's important to consider exactly how to communicate that. And ensuring that the products conform to accessible design principles and kind of collating research on that. And this is a really crucial one. I think it would be really great as the centres are developing these products to ensure that we have a kind of repository of forecast product designs with example of use cases, because I think that would really help to share knowledge and help to implement best practice. And perhaps even, if centers are willing to share their code as well, I think that would be great to help spread that, the ability across the forecast centers to pull through the information. And then finally, to ensure we carry on with that cross-disciplinary collaboration, we need to engage with experts in communicating complex information. I've listed some of the kind of relevant experts there, and also experts in graphic and product design. As meteorologists, we have a lot to give to this, but there's so many other experts that we need to engage in the process to ensure that we're really optimizing how we communicate the information. And then the final area is the resources side. So we said we want to encode the ensemble tracks in a consistent format and disseminate them in a stable and a timely manner. And we did come up with a suggested path for this from TCPFP, and I'd be interested to get feedback on that. Because one option could be that at the moment, only ECMWF actually use the WMO standard buffer format to disseminate their ensemble tracks. And that could be something that WMO could request all the NWP centers to do. And ECMWF would be willing to provide training material and, crucially, the encoder and the decoder to enable the centers to use the buffer files. And they could be then made available via the GTS. So this would enable, all the centers to access them, again, crucially, with the training material and the code to exploit those. And it's important that we should include pre-Genesis tracks, in addition to, only including them once the storms are named. But we need to formalize a kind of consistent naming format for these storms, because that doesn't exist at the moment. And it's also possible we could look to perhaps use this new archive as a kind of replacement for the TCXML. Ideally still at NCAR, at the Research Data Archive, where they've done a great job of hosting the TCXML data. But we may need to look at decoding that into a more user-friendly format for the research community, such as NetCDF. So I'd be interested to hear feedback on that. Right, it's my final slide. Our future plans, we hope to publish the finalized version of our phase 1 document early in the new year. And then we move on to the next phase of our project. In practice, although it's split into these phases, we know that it's not as neat as this, because really, so much of it is looking across all of these topics, but we've tried to at least try and give some structure in terms of which we look at. So the next thing we're going to focus on is intensity and structure. And what I just wanted to comment on here is that this couldn't be better timed, because, for example, the ECMWF ensemble next year is upgrading its resolution from 18 kilometers to 9 kilometers. And at that point, they're also stopping to produce their deterministic forecast. So the deterministic forecast will just be kind of the control from that ensemble. And so I think it is time to look again at what can global ensembles bring in terms of intensity forecasts. Because obviously in the past, resolution has been an issue, but that's kind of changing. So I think it's an exciting time to be starting to look at this. So one of the things we'll do is have another workshop, so do keep your eyes open for information on that. And then the final phase, we'll be looking at the use of ensemble data in rainfall and storm surge. So thank you. And if you'd like to get in touch, do please email either Jason or myself, or both of us, and because we'd love for people to get involved in the project, whether you're from a research side or from the NWP side or forecaster side or the social science side. We'd love to engage with you and have you involved in the project. So thank you very much. I've probably gone over time, sorry.
Give you time to catch your breath there. No, thank you very much. No, you can hold on to that. So Helen, if you could stay up here, and can I ask KK and who was the other? Oh, and Wei to come up, and also Julian, just the people who presented. We have time for a few questions. I think we're running a little bit behind, but I think that's okay. Okay, hold on, Roger. Let's get the folks up here. Yeah. So Julian's coming up. And also, while they're coming up, I wanted to say that, this is great. Thank you, Helen. Unfortunately, the stuff that you presented has not really been captured in any of the recommendations to consider for the breakout sessions. So I urge people, when you are in the breakout sessions, to think about some of the material that Helen presented as well as possible fodder for recommendations. Okay, so we have time, about 15 minutes or so for questions. So I saw Roger first, and then John. Okay, you have a, yeah, go ahead, Roger. It's hard to hear you. Yeah, is the microphone on too? Joe's coming with the.
Okay, thanks. Yeah, I've been a bit surprised this morning because I haven't heard anybody talk about how Genesis really works or how people think it works. I've seen no mention of the importance of deep convection in Genesis. And when people are looking at these various products from models, they don't seem to be very interested in where the model has the convection. But we know from a dynamical point of view that storms form because there is convection in a region where there is rotation, basically. And if we don't know where the convection is in relation to the rotation, how can we make an assessment of these models? How can we assess whether they're capturing Genesis or likely to capture it? So I just fire that as a comment. In my view, we need to worry about where the convection is in relation to the rotation.
I guess a couple of comments on that. I think in Rajeshree's talk, so from a research point of view, I think there's still a lot of work going on looking at tropical cyclogenesis pathways and trying to understand the different pathways that the top down, bottom up, and various other, the roller diabetics. I think there is still a lot of work going on in there. But I think your comment or question was more around operational approaches. I certainly think that in the research area, there's still quite a lot going on in there.
Okay.
Okay, John, and then we're going to take a question online. Oh, sorry, did someone, well, okay, sorry. We'll come back to you, John. Go ahead with your question, sorry. And then we'll go to Jack and then John.
Yes, so thank you. So I'm very interested in some of the recommendation from, especially from the Helen, the last. There are two things that I would like to emphasize. The first thing is like the recommendation for the different centers to provide the pre-genesis information. Because actually in Vietnam, for example, like for statistics, we have about 40% of the landfall cyclone is just a tropical depression intensity, and 35% is a tropical storm with the intensity of less than 25 meters per second. So it means like the tropical depression and weak tropical storm is very important for Vietnam and in South China Sea especially. So that's the good suggestion I should say. The second thing is like for the track, the unusual track, and also the suggestion for have a method to screening the track in different large-scale factors. So I just wonder if there are any standard track, a standard method to do that. For example, like you suggest ECMWF can provide the code, the decode, and coding for the buffer format for tropical storm track. So how about the classification of tropical storm track from ensemble products to have the forecaster to identify some difficult unusual track depend on the large scale factors and also the tropical storm interaction. Thanks.
Yeah, thanks. It's great to hear that you could utilize that forming storm information. That's great. Your second question, did you say you'd like the precipitation information as well? Is that what you said? Did you mention precipitation? Is that
no, the track?
You were still talking about
Yes.
about the track. Yeah. So I don't think there. I think we really need to look more at those situations with the unusual, particularly like bifurcating cases and like that. I think there needs to be more work to look at kind of innovative ways to exploit that. I think generally often it is still looking at how can we use the ensemble information to kind of recreate a kind of cone type graphic. But I think in Australia, like if with your new forecast confidence areas, they can have slightly strange shapes, can't they? I think Ravi said that, you know, so far there hasn't been any cases like that, but in principle, that would allow that. I don't know whether you want to say anything on that.
Yeah, there is possibility for the objective techniques to throw up solutions that are unfamiliar to forecasters and the public, but that are genuinely driven by the NWP ensemble data. I think that's just a change that we'll see people get used to.
Yep.
Okay, thanks. Make one comment on, in terms of the dissemination of ensemble tracks, that there is progress being made here because is recently in WMO, there has been, we have changed the distribution of vortex parameter files from the global NWP centers from a suggested you do it to a mandatory. So that should increase the availability. That's one of the first steps in increasing the availability of the vortex parameter files, which as we've seen is a necessary first step in these super ensemble approaches.
Okay, thank you. So we're going to go online now. I think Jack, Bevan, you had your hand raised. Is that right? You want to unmute yourself?
That's correct. And question for Julian and anybody else who wants to jump in on it. All the work we've done, or I'm seeing tonight, is focus on the tropical cyclone and the track ensembles and the tropical environment. But as we do 5, 6, 7 day forecasts, particularly as the storm starts getting towards the western end of a subtropical ridge or starts interacting with the mid-latitudes, it may be that we need more information, not just on the tropical cyclone and the tracks, but on the confidence in that we can assign to the models that they break down the subtropical ridge or keep the subtropical ridge strong, or if they misplace troughs or trough too strong, trough too weak. What's in the works to give forecasters better guidance of that assessment? I know when I'm on duty, I ask the guys at WPC a lot who look very closely at the mid-latitude ensembles, what are their thoughts on the trough placement and the trough strength, which can be a big deal for a potential recurving storm near the U.S. East Coast. Anything that we could get to help that would be another piece of this puzzle. So what's in the works there?
I think I would say that in terms of the ensemble products, which both myself and Helen were showing, obviously the spread in the tracks of the storms is implicit within that is the perturbations to the model solutions, which includes impacts on the wider synoptic environment, such as the subtropical ridge. And I mentioned that we need to also look at the possibility of perturbing tropical cyclone specific perturbations, but currently implicit within the systems we use, it is applying a perturbations across a wider synoptic environment. So I don't know if that helps at all. But there was a point I was wanting to make just now in terms of the unusual tracks and the value of multi-model ensembles in this approach, because we do find, as I illustrated in one of those cases, but I think it's Hurricane Eta, often the individual ensembles are very much enslaved to their parent deterministic model in terms of the spread. And I think, I mean, Helen showed the value in overall, based on or hemisphere-wide statistics, the value of multimodal ensembles. And I think that's certainly something to emphasize. Don't always look at one model's ensemble. There'll be somewhere one particular model might be quite poor and very good in another case. And looking at the whole spread of the multi-model, I think it has great value here.
Okay, thanks. We have time for a couple more questions. So John, yeah, go ahead.
Yeah, I've got a couple of very, very short specific questions. But first, I'd like to follow up on Roger Smith's comment on the theory of genesis and so on. In some ways, this section deals with, I understand the logic, you know, of the ensembles for combining the two, but they're quite different to the extent that Genesis we have no fundamental understanding of. We don't have a theory for the threshold sea surface temperature. There are competing theories, you know, the marsupial pouch and so on. So there's large theoretical unknowns. On a fundamental level, we don't understand Genesis, whereas I think on the fundamental level, we understand motion. You know, and so it's governed by, you know, sort of vorticity dynamics, the primitive equations, and so on. And it comes down to specification of the initial state and the NWP models governing the surrounding flow and so on. So they're quite different, and I think that in a way should feed into the recommendations and so on. But that was my little speech. Now, two short questions. The first is on the on the cyclone tracks forecast school in the North Atlantic. Every tropical cyclone has a airplane go into it, and it doesn't just measure the intensity in the center, it drops sons around the surrounding track. So there's a big data difference. So does that feed through into the skill for the different basins of the North Atlantic tracks through the ensembles and super ensembles, or not? You know, is it much more skillful in the Atlantic than in the other basins? And because of this observational difference, and whichever way to answer to that question is yes or no, you know, what are the implications for recommendations and forward and so on for that? And then my second question is just a general one on ensembles. In ensembles, that there's 100 ensembles or something, so you have 100 initial conditions, and you do Kelvin filters and all this sort of stuff. Do you vary the cyclone structure, and do you vary the asymmetric gyres in the structure of the cyclone and so on in varying the initial conditions for the ensembles? That's it.
Can I just comment on that first question relating to the recon data? I think the only way to really establish the impact of the recon data is through data denial experiments, and I know there are quite a few of those out there, and they're done quite regularly. I don't think you can do it by just comparing the Atlantic errors with other regions, because each region has its own error characteristics. So, for example, in the Northeast Pacific, where we have much proliferation of straight running storms, the model errors tend to be a lot less than in Atlantic and Northwest Pacific, where the tracks can be a lot more convoluted. So I think if you're going to ask the question about the value of recon, it really probably can only be established by data denial experiments in the models that are being run.
Someone want to tackle the second question?
Yeah.
Briefly?
Yeah. Yeah. Now, today, all ensemble prediction systems are mostly atmospheric, no ocean coupling. So TCP/FP may consider that coupled ensemble prediction system performance. So ocean initial condition, stochastic sense, how it react with atmospheric model, that is need to be studied.
Yeah, so just to firstly comment on John's question, and then I'll comment on that. I think it would vary between, as Emily were talking about super ensembles potentially coming from multiple centers, and each center would have their own way of perturbing that ensemble. Speaking from the Met Office ensemble point of view, we don't currently do any specific perturbations to the TCs themselves. So the differences that you see are purely due to the kind of wider perturbations. We are actually looking at potentially putting in some perturbations, specific to the TC, because particularly in our ensemble, we are currently under dispersive, we are under spread for track and intensity. So we are looking to do that. But I think it will vary from center to center. In terms of the point on coupled ensembles, yeah, ECMWF is a coupled ensemble. We've recently moved to be a coupled ensemble, and that does help to a certain extent with reducing any over deepening. But actually, we've found that our new coupled version has made the ensemble intensities more weaker. But certainly, coupling is obviously an important point going forward, and I think the ensembles will increasingly become coupled.
Thanks. So we have time for one more question, and that's Mike Montgomery, I believe, has his hand up. Yes. So Mike, if you can unmute yourself, and then feel free to ask.
Excuse me? Hello, Robert. Nice to see you. Nice to see everyone, Julian and all my friends there. I just, can you guys hear me okay?
Yeah, we can hear you. Good to see you, Mike.
I wanted to echo a couple comments, and then I don't really have a question, maybe a recommendation. I want to echo Roger's comments that the location of the convection in relationship to where the rotation is absolutely crucial. And that could, in fact, play an important role in helping determine how to create better ensembles, in fact. Not just errors in the error covariance matrix, just kind of random. You might be more selective. The other comment I want to make is that I think these ensembles offer a great opportunity to look at the genesis process in the actual experiments. I know there's a lot of runs and there's a lot of work to be done, but one could learn something about the pathways to genesis in these ensembles that have already been presented this morning. That could be quite useful. And finally, John McBride, I enjoyed hearing from John, and I was a little bit surprised, however, when he said that we don't have understanding of genesis. I would actually respectfully suggest that, in fact, we do, and that unlike what John suggested, is that the track problem obeys the vorticity equation, the genesis problem obeys the vorticity equation as well, and the thermodynamic equations that are involved. So, in any event, we can have that discussion and debate, but I just wanted to make those points, and maybe they could provide some usefulness. But ensembles would be a fantastic thing with these experiments that have already been done. I know Julian is waiting for us to do some of that with the UK Met model, so he's been very patient. I appreciate that. Thank you.
Okay, thanks, Mike. Did anyone want to quickly respond to Mike's comments?
I could just say I definitely agree that the ensembles have a lot to provide in terms of research as well, because, yeah, they give hundreds of examples each run of where a storm has developed in the forecast, and I agree that it is, as well as using that in the forecast sense, using that in a research sense is an underutilized way to exploit the benefits from ensembles, so I couldn't agree more with that.
Yeah, thanks. I think a lot of the discussion that we've had here, these questions can really perhaps guide some possible recommendations too. So I'm going to go ahead and end it here. I'm sorry, I know there's more questions, but we're really running late. But I want to thank our presenters, and thanks Andrew and Hui for a great topic. Okay, so we now are scheduled to what? Okay, yeah, we're going to show that. So we're going to go into a break, and then we're going to go into the breakout session. So we are a little bit behind on our schedule, but the hard cutoff, I believe, is basically 1:30 for the excursion. So lunch was scheduled to start at 12:45. Right now it is 11:10. So can I ask people to get to the breakout sessions by 11:30? That'll give us about an hour and 15 minutes. So 20 minutes for break, bathroom break, and so forth, coffee. And then please go to your breakout sessions. These are some of the suggested recommendations. Is that right, Joe? Okay, so consider these recommendations when you discuss in the breakout sessions. They're ones that maybe could be modified, consolidated, irrelevant, or fantastic, or whatever. That's the QR code. So Kim, did you want to say anything real quick before we go? And those who are online who would like to participate in an online breakout session, there's a Jamboard, which I believe there's access to. Yeah, here you go, Kim.
So I did want to mention that I quickly updated the document this links to, so that tiny URL, it's the same format for all of the sessions. It links to the recommendations that Helen Titley just presented. So there is that in there as well. They aren't in the Jamboards because I wasn't able to get that in there in the last 5 minutes. But beyond these listed in the document, you can also look at that PDF to talk about those recommendations as well. I just wanted to make sure that you were aware that that's linked in there too.
Thanks, Kim. So let's go ahead and take a coffee break and try to get to your breakout sessions by 11:30.
Ladies and gentlemen, there is an announcement for Uluwatu arrangement. Yes, the first, please be ready in Patra Hotel lobby at 1:30. Remember, 1:30, you should be ready in Patra Hotel lobby. And then we will move to BMKG regional office. During today's activities, please always wear your name tag because your name tag is also your ticket to go to inside Uluwatu. So please always wear your name tag. And then there is a monkeys in Uluwatu. Beware with your hat, your name tag, your glasses, your handphone, because the monkey is very fast. And you will need bananas to exchange for your things for the monkeys, okay? And then there are a leader in every bus. Please remember your bus leader. Please remember your bus leader or local committee inside your bus. Do not forget your bus number. Okay? Do not forget your bus number. You cannot go inside other bus. No. You do not forget your bus number. If you bring spouse, local committee will provide name tag for your spouse, and then you can contact BMKG Secretariat for the name tag. And then you can check your bus number on the bus door, and also here. Remember your name and the bus number. That's your bus. So 1:30, go to your own bus. Okay? Thank you very much. Remember, 11:30, breakout session start. Thank you very much.
And as you're all moving off to the break, I just want to put in a plug for there will be a session that Rabi will be holding for anybody that's interested in looking into the objective technique that we're implementing for forecast confidence areas and forecast confidence cones. At the end of tomorrow's session. So it's tomorrow, at the end of tomorrow's session here, there'll be a special session that Rabi will be here to take people through and explain how the process works and answer any questions.
And one more thing, a local committee will wearing red. So you can find local committee. Red t-shirt. Like this picture. Thank you very much for your attention. If you have any question, you can go to BMKG Secretariat. And then if you need name tag for your spouse, the one who already filled the form before, you can go also to the BMKG Secretariat. Thank you very much.